Today we're going to talk about the true reactivity of aluminium. Now, as you can see from the reactivity series here, that aluminium is right towards the top, which means it's a very reactive metal. But we treat it like it isn't a reactive metal. We drink things out of aluminium, we have our sandwiches wrapped in aluminium, we cook in aluminium, and we often call it tinfoil, but it's aluminium. Okay? And here I can happily drink out of aluminium. Now, if it was really reactive, this acidic drink, because Cokes and Pepsis and things like that have an acidic nature to them, they would actually start reacting with the can, but they don't. And we're going to explain why in this video. So first of all, we've sanded the outside of all of these to remove the paint so the aluminium is exposed. Also, by sanding it, we've removed the aluminium oxide, the oxide layer. That's why aluminium doesn't look very active, because it's got an aluminium oxide layer around it, because the aluminium reacts with the air. So you can see, as I put this Nespresso capsule, which is made of aluminium, into this concentrated hydrochloric acid, you get the bubble, really furious reaction there, really furious. Okay, and you'll start to see this horrible colour from all that aluminium starting to be reacted and therefore got rid of. So now you can see we've got this Pepsi can, and you can see it's been scratched all around the outside again. I've sanded it to get rid of that paint layer and get a bit rid of some of the aluminium oxide as well. And you can see straight away that we're getting this furious reaction, this bubbles, because that concentrated hydrochloric acid is going mental with the aluminium, okay? Because the aluminium is truly reactive. It's not unreactive. Remember, it's that layer of aluminium oxide that makes it seem unreactive. And you're going to see how mental this is, because we didn't take into account how concentrated it was going to be and how reactive it was going to be, and it flowed everywhere and made a complete mess in the fume cupboard. So now we move on to the tin can. Now, tin cans are called tin cans because they're usually steel underneath with a tin coating around the outside. So we're talking about the reactivity of tin. And you can see here that it's bubbling, but it's not really bubbling very much. And actually what you'll find when we skip right to the end, okay, that you can see that it's just really cleaned it. That's all it's done. It's just cleaned out all of the rubbish that's on the outside, the glue and everything like that. And basically, it hasn't really reacted with the tin. That's because tin is lower in the reactivity series. And that means that basically this tin can, if I left it for hours and hours, might react. But for now, it's just cleaned it up. So now we're going to go on to the aluminium can. And you can see the aluminium can is no longer a can. It's plastic. All the aluminium has reacted because aluminium is a very reactive metal. And you can see that it's flexible because it's just the plastic, which keeps the Pepsi tasting very, very nice, not contaminating with the metal. And you would be able to see all the Pepsi in, but we put concentrated acid in there, and there's a bit of Pepsi just at the bottom, and it leaked all out because it even destroyed a little bit of the plastic. But you can see that aluminium truly is very reactive. Let's go back and look at our Nespresso capsule, and you can see it's got plastic now, so all the metal's reacted, all the metal's gone apart from the lid. Okay, you see I can squash it, and oops, dropped it. Okay, but here you go. You can see totally plastic. That plastic stops the coffee from tasting bad because the metal can make it taste bad. Just to show the final comparison, you can see the Nespresso, all the aluminium has reacted, and you're just leaving the plastic, and also with the aluminium can, all the aluminium has reacted again, so aluminium, very reactive metal, and you can see that the tin just merely being cleaned. Now this took only 5 minutes because we used concentrated hydrochloric acid, but you can definitely see the difference in reactivities. So it would not be a proper aluminium video if we didn't do a really cool looking experiment. So we're putting bromine in, and bromine strips all the aluminium oxide off of that aluminium, showing the true aluminium underneath. And as it strips it off, it then furiously reacts because the bromine is so reactive, and so is the aluminium, and you get these wonderful kind of colours that you can see right here and enjoy.